Hello everyone. Welcome back to another video tutorial. In this video tutorial I will going to discuss about some basic information regarding nanotechnology. These are the nanotechnology. History of nanotechnology. What's so special about the nanoscale? Nanomaterials, preparation and characterization, and finally application of nanoparticles. Let's start with introduction. Nanotechnology. According to the National Nanotechnology Initiative, nanotechnology is the understanding and control of matter at dimensions of roughly 1 to 100 nanometers, where unique phenomena enable novel applications. Whereas the size range of nanoscale from approximately from 1 nm to 100 nm. How big is a nano? To understand how small a nanometer is, we typically compare the nanoscale to objects that we know how big or small they are. Look at the scale bar. This shows the basic length scale of nanomaterials and their comparison to biological components. Here you can see the size of buckyballs. One DNA strand, protein, and viruses are in nanoscale range. History of nanotech. There are a number of relatively famous examples of ancient artifacts which were created using nanocomposites. For example, 2000 years ago Greeks and Romans were used sulfide nanocrystals for dyeing hair. 1000 years ago colloidal metal salts used for staining the cathedral windows. The Lycurgus cup, made up of gold-silver alloyed nanoparticles, which were distributed in such way to make the glass look green in reflected light, but when light passes through the cup, it reveals a brilliant red. Richard Feynman, he who considered as the father of nanotechnology. The American physicist and Nobel Prize laureate introduced the concept of nanotechnology in 1959. During the annual meeting of American Physical Society, Feynman made the hypothesis, there's a plenty of room at the bottom. He actually spoke about possibility of making smaller molecular machines. So this is the reason, he is considered the father of modern nanotechnology. After 15 years, Borio Taniguchi, a Japanese scientist, was the first to use and define the term nanotechnology in 1974. After that in 1981 IBM developed scanning tunneling microscope, then, 1985, buckyballs developed by a group of scientists from Rice University. And then 1991, CNT was discovered by Sumio Iijima. What's so special about the nanoscale? Nanoscale materials have larger surface areas than similar masses of large-scale materials. If surface area per mass of a material increase, a greater amount of the material can come into contact with surrounding material. For example, consider a cube of 1 meter cube volume. It has surface area of 6 meters square. If this cube of same volume divided into 8 small cubes, then the total surface area increased to 12 meters square. Further divide the cube leads to increase in surface area. This makes material more chemically more active. Next is quantum effects of nano. This unique optical properties of nanomaterials arises due to quantum size effects. When size of the nanocrystals is smaller than de Broglie wavelength, electrons and holes are spatially confined and electric dipoles are formed, discrete energy levels are also formed. And nanoscale at which much of biology occurs. Many of the inner workings of cells naturally occur at the nanoscale. For example, hemoglobin, the protein that carries oxygen through the body, is 5.5 nanometers in diameter. A strand of DNA, one of the building blocks of human life, is only about 2 nanometers in diameter. Using the natural nanoscale of biology, many medical researchers are working on designing tools, treatments, and therapies that are more precise and personalized than conventional ones and that can be applied earlier in the course of a disease and lead to fewer adverse side effects. So these three important properties makes nanoparticles more special. Nanomaterials, preparation, and characterization methods. There are two general approaches for the synthesis of nanomaterials, such as Top-down approach and bottom-up approach. Top-down approach involves the breaking down of the bulk material into nano-sized structures or particles. Top-down approaches are inherently simpler and depend either on removal or division of bulk material or on miniaturization of bulk fabrication processes to produce the desired structure with appropriate properties. Bottom-up approach refers to the buildup of a material from the bottom, atom by atom, molecule by molecule, or cluster by cluster. Nanomaterials. There are different characterization tools are available to study the structural, optical, electrical, and magnetic properties of nanomaterials. Such as for morphology analysis, electron microscope are using. For crystal structure analysis XRD is using. Finally, nanoparticles. As nanomaterials have exclusive, advantageous physical, chemical, and mechanical properties, they can be applied in different fields such as biomedicine, aviation and space, chemical industry, optics, solar hydrogen, fuel cell, batteries, sensors, power generation, aeronautic industry, building/construction industry, automotive engineering, consumer electronics, thermoelectric devices, pharmaceuticals, etc. For watching this video tutorials. If you like this tutorial, please share with your friends. Thank you.